Hey grade 7s, this week we are going to revise everything that we've been doing during the lockdown period, starting with the geometry that we were busy doing at the end of last term, just to revise that, and then we're going to revise all the factorization that we did and the fractions that we've done. So this week is going to be a revision week. Today we've got quite a lot to do, so let's get going. Let's start with naming angles. Remember that when we name an angle, we can name it in two ways. It's to indicate where the angle is on the drawing. That is the point of naming angles. So if we have a look at this angle, we have an X, Y, Z, and the corner here, this vertex at Y has been indicated. That means that this is the angle that we're talking about. We have two ways of naming it. The easy way of naming it is saying that that is angle Y. That doesn't look good at all. Let's write it here, angle Y. But the better notation to use is the three-letter notation. And when we use three-letter notation, we say that is angle X, Y, Z, or angle Z, Y, X. We name the ends of the arms and the angle in the center, and we put a little hat on its head to say that is the one, that's the angle that we're talking about. Alright, the next part that we move on to is classifying angles. There's a difference between naming an angle and classifying an angle. Naming the angle is just to say where it is. When we classify an angle, we say how big the angle is. So when we classify an angle, if we have a look at this angle here, this is smaller than a square corner. Anything that is smaller than a square corner being a right angle, which is 90 degrees. So anything less than 90 degrees, we call an acute angle. Remember our abbreviation for angle, instead of writing angle every time, we can write a sort of an L just with a little bit more of a slant. Alright, and that is the angle, the symbol for an angle. Our next angle is exactly 90 degrees. So if it equals 90 degrees exactly, in other words it's a square corner, we call that a right angle. So we're going to write it as an abbreviation, our right angle. Our next angle is larger than 90 degrees. So it's larger than 90 degrees, but it's less than a straight line. And a straight line is also known as a straight angle. So it's less than a straight angle, which is 180 degrees. And then we're going to call this an obtuse angle. Please, obtuse with an S. Right, let's move these up a bit. Okay. Our next angle is exactly 180 degrees. And when an angle equals exactly 180 degrees, we call that a straight angle. Like that. If we have an angle that is greater than 180 degrees, so it's greater than a straight line, but less than all the way around is 360 degrees. So it's greater than a straight line, but less than 360 degrees, we call that a reflex angle. Alright, in other words, this arm was over here, and we took it and we went all the way around to there. It's a reflex angle. And then the last angle we need to look at is we had our one arm of our angle, and we took the other arm and we went all the way around, and now it's lying on top of the arm that it's where it started. That is exactly equal to 360 degrees, and that angle we're going to call a revolution. Right, that is a revolution. The last part of angles that we learnt about were complementary and supplementary angles. Complementary angles are angles that add up to 90 degrees. So if I ask you what the complement is of 35 degrees, I'm asking you what I must add to 35 to get to 90 degrees. And so the complement of 35 is going to be 55 degrees. Likewise, if we look at the supplementary angles, they add up to 180 degrees. So to get to 180 degrees, let's say I give you an angle that is 80 degrees, and I ask you what the supplement is of 80 degrees, I want to know 80 plus what is going to give you 180 degrees, and that's going to be 80 plus 100 degrees. So 80 and 100 are supplementary angles. Alright, then we looked at classifying triangles. Triangles was our next section. And when we classify triangles, there are two ways in which we classify triangles. There are two things that we look at, two properties that we use. The first property that we use is we look at the sides and the lengths of the sides of the triangle, and we have a look at how many of those sides are equal in length. All of them, only two of them, or none of them. And the other thing that we look at is the angles, the sizes of the angles. So let's start with the sides. If we have a triangle where none of the sides are equal in length, we call that triangle a scalene triangle. And remember, our symbol for a triangle is a little triangle. Okay. If we have a triangle where two of the sides are equal, we call that an isosceles triangle. And if we have a triangle where all the sides are equal, we call that an equilateral triangle. Alright, now, a scalene triangle has no lines of symmetry. An isosceles triangle has one line of symmetry. It goes from the one vertex and then through one of the sides. Alright, also with an isosceles triangle, the angles opposite the equal side. So there's an equal side, there's an equal side. The angle opposite this equal side and the angle opposite this equal side, those angles are also equal to each other. In a triangle where all three sides are equal, our equilateral triangle, all three angles are also equal to each other. They all equal 60 degrees, each angle equals 60 degrees. And there are three lines of symmetry. Those lines of symmetry go through a vertex, through the opposite side, through a vertex, through the opposite side, and through a vertex, through the opposite side. The next property we have a look at is the angles. We have a look at the size of the angles. If all the angles are acute angles, in other words, none of them are right angles, they're all smaller than a right angle, then this is an acute angled triangle, like that. The next triangle we have is a triangle where we have one right angle. Remember that we can't have a triangle that has more than one right angle. But if our triangle has one right angle, then we call it a right angled triangle. And if our triangle has an obtuse angle, one obtuse angle, it can't have more than one, but if it has one obtuse angle, we call it an obtuse angled triangle. Right, so if we want to fully classify a triangle, and we want to fully name it, we have to name it according to its sides and according to its angles. So if we have a look at these triangles over here, we have a look at this first triangle, all the angles are acute angles, all the sides are different lengths. So this is an acute angled scalene triangle. This next triangle has a right angle, so it's a right angled, none of the sides are equal, so it's a right angled scalene triangle. And this one is an obtuse angled scalene triangle. If we look at this isosceles triangle over here, all the angles are acute, so this is an acute angled isosceles triangle. When it comes to an equilateral triangle, we know that all the angles are acute because we know that they're all 60 degrees, so we don't actually have to write that. We can just say it's an equilateral triangle. If we have a look at this scalene triangle, it has a right angle, so it's a right angled scalene triangle. Right. Then, if we move on, we have a look at the interior angles of a triangle. if we look at the interior angles of triangles, we know that the interior angles of a triangle add up to 180 degrees. So if we're given 2 of the 3 angles, we can calculate the missing angle. We do that by saying the interior angles equal 180 degrees. So we subtract the angles that they've given to us. They've given us an angle of 90 degrees and an angle of 50 degrees. So we say 90 degrees plus 50 degrees. So we're going to subtract those two. Then we say 180 degrees minus, if we add those two together, I'm going to get 140 degrees. And that is going to give me a leftover of 40 degrees. So that means x equals 40 degrees. If we have a look at this isosceles triangle, it's a little bit harder because they've only given us the size of one of the angles. So same thing again, we take our 180 degrees, we subtract what they've given us, and that's going to leave us with 110 degrees. Alright, now that 110 degrees has to be split equally between those two because this is an isosceles triangle, so we know that those two angles are equal. So we're going to say 110 degrees divided by 2, and we're going to get 55 degrees each. So therefore, x is going to equal 55 degrees. Then we move on to the properties of the quadrilaterals. The properties of the quadrilaterals I'm not going to go into in detail here. I'd like you to take your worksheet that you got previously and have a look at those properties and go through them very carefully. They're very important. Remember, there are 3 things that we look at when we look at the properties of quadrilaterals. One of them is the sides. When we look at the sides of the quadrilateral, we have a look at which sides are equal. Are all the sides equal? Are the opposite sides equal? Are the adjacent sides equal? Adjacent, next to each other. Opposite, looking across a distance at each other. The other thing we look at with the sides is, are they parallel? Are the opposite sides parallel? Is there just one set of sides parallel? Are both sets of opposite sides parallel? Or none? Alright, the next thing that we have a look at are the angles. Which angles are equal? Are the opposite angles equal in size? Are all the angles equal in size? So angles are also very important. And then the third thing that we look at is the diagonals. Remember, diagonals go from corner to corner through the center of our shape, of our quadrilateral. Now with the diagonals, we check, do they bisect each other? Do they cut each other in half? Are they equal in length? So the diagonals are quite important. And also when they bisect each other, do they bisect each other at 90-degree angles? Are they perpendicular to each other? Alright, so those are the properties of the quadrilaterals. Please go and study them. They're very important. And then the last bit that we did are the interior angles of a quadrilateral. Just like the interior angles of a triangle, it works exactly the same way, except that they add up to 360 degrees. So we take our 360 degrees, we subtract what we're given. So we were given 98 degrees, we were given 72 degrees, and we were given 80 degrees. So we're going to take our 360 degrees. Let's see how much we need to subtract. 98, 99, 100, so that's 170, plus another 80 is 250. Right, so 360 degrees minus 250 degrees is going to give us 110 degrees. So therefore, x equals 110 degrees. And that's how we calculate the interior angles of a quadrilateral. That is all the geometry that we need to revise.